Good afternoon, everybody. Welcome to today's Liftoff webinar. My name is Christine Longroy, Senior Director of Ecosystem here for Lyft. This Liftoff webinar is brought to you by Lyft, the National Advanced Materials and Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. Lyft is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security. Today's presentation, we have Robert Mihal, Vice President of Administration for Osirius Group, who is presenting Agile solutions for complex engineering utilizing error-proofing productivity tools for quality results. Industry 4.0 is not a one-size-fits-all, so buckle up, everybody. This is going to be a great presentation. Rob has 40 years of experience in IT and manufacturing industries, supporting clients in automotive, defense, consumer packaged good, and retail segments. So Bob's got a lot of experience and going to share that with you today. So Rob, thank you for joining us. Welcome and take it away.
Well, thank you for that lovely introduction. I appreciate that. So I'll just kind of show the agenda real quick and go through the content that we have prepared for you. So we'll start a little bit about who is Osirius Group and where we come from and what do we do. Talk a little bit about the overview of error-proofing concepts, the idea, what's the basis, what are the business drivers, and go through some examples that Osirius Group has implemented for some of our customers to give you some ideas on how that can be applied in the on the plant floor to help with people's manufacturing issues. And then we'll have plenty of time for Q&A in order to address any specific questions, concerns that people might have, and things that they may want to learn more about. All right. So about Osirius Group, we generally we do engineering and manufacturing services. We work with customers all over the globe. We start at anywhere from product design all the way through production support, all throughout the product and manufacturing life cycle. We've entered the programs with the customers at different phases based upon their needs and business issues that they're facing. And we work across automotive and defense industries primarily, in all sorts of engineering and manufacturing applications. Osirius has been around for more than 20 years, as our CEO was leaving the executive branch of General Motors and was encouraged to go and do his own thing at the time. So we've been working as an offshoot of that, and Tim Smith, who is the CEO, unable to join us as a presenter today, but I'll be happy to get to know you and your needs as we go forward. Our team is very experienced. We have people that are usually, like myself, gray beards or gray hair, that have many years of experience, have maybe on their second careers now, having been their first career at other companies. And like I said, the company, Osirius itself, is more than 20 years as its own entity and long range of success. I know this is way too much to go through in any detail, but it's just a representative example of some of the things that we do across the life cycle of products. Everything we do starts with project management and control and managing the data and information that's important to the program. And then whether it's product engineering, process engineering, working on shop floors, doing body or general assembly, or other types of assembly, or paint shops, all the way through installation launch. We've done other things that are specific to localization, taking something from one market and introducing it into another. And we'll have an example that can go through some of that. We also offer our own supply chain and procurement services as part of our turnkey support that we do. And we've also, been branching out into other areas more recently in the last four boxes on the bottom, as far as software, high and low pressure die casting, other product innovation and defense solutions, as well as railroad and remanufacturing for different things in that kind of industry. So broad, diverse experiences and a lot of expertise, to offer. Just briefly, at a glance, we've got our primary headquarters here in Detroit area in Birmingham. We've got our French headquarters in outside of Paris, and one of my colleagues from that team is the head of our manufacturing group, Diego Raviolo. He will be on the line also to support some of these technical examples and talk through some of the things that we did to help our customers solve issues in reducing the errors that they had in their processes. And with our global reach, as I mentioned, Tim was executive at General Motors. He was in charge of Latin America, Middle East, and Africa, and therefore he has a lot of connections in those regions. And we have a lot of our resources that we use from time to time that are based out of those regions as well. So that's kind of given us this global approach. And as we've worked with customers on difficult situations in different markets, and in markets where maybe others may not be as inclined to go into. And you see across the bottom a list of some of our customers. Again, all across automotive industry, many different OEMs, as well as others in the defense contractors, and even in the areas of agricultural and farm equipment. So on to the main subject at hand, which is talking about error-proofing concepts. So I just wanted to start with a little foundation and then build from that. So manufacturing errors happen. There's many different reasons, and it's up to the leadership in order to help determine what the causes are and help to resolve those causes with solutions. And then those solutions can take many different forms. But really, the errors cause increased costs is the biggest driver. It causes rework, it causes excessive scrap, and it causes warranty repairs, which is again all things that hit the bottom line. And then related to that, the reduced quality. Maybe there's inconsistencies in some of the end results, which cause customers to be unsatisfied with the products, and that could also lead to lost sales. So there's lots of business reasons why eliminating errors is very important, and the process and how you do that is what we're going to talk about. So there's really two primary methods to address errors. One is to be preemptively planning and avoiding making errors in the first place. That's going to be based on prior experiences. So you have to know what was done before and why, what caused errors in the past. And it always boils down to gathering data and analyzing that data to understand where that points you to as far as the root cause of those problems. And then similarly, retroactively identifying errors and determining root causes is the alternative to having done it ahead of time. Observation of the process in action is very important for the people helping to resolve those issues. And again, gathering data, analyzing that data, understanding what it's telling you as far as where deviations might be happening, where steps might be out of order, although those things can be causing your problems. And then specifically on data analysis, you got to have that data gathered. There's many different ways to gather that information. There's manual methods and automated methods. And automated methods are those that help you to automatically record information, and track it. And one of the things that we'll talk a little bit about as well is traceability, being able to start with a component and follow it through the process and understand what happens to it in each step along the way. And in documenting the changes and where deviations might be happening. There's systems and process inventories that help us to understand, what are the steps along the way, and what maybe looking at the process might help to identify areas that are prone to human error, perhaps, or in understanding the sequence of things, how they might be done in incorrect order. Quality checking steps within the process as well. There's a lot of people that follow the belief that you can check your way into quality results, and I would say that that has its limitations. You can only quality check so much before you're costing too much in your quality checks versus how improving the causes of those problems in the first place. And you know just want to close this particular slide with, error proofing is a business driver for what a lot of people might be calling Industry 4.0, which is the digitization and use of automation and technology to address a lot of the issues. It helps out, also helps in automation in data gathering and some of the analysis, and leading all the way up to more current developments like the applications of AI. So let's talk a little bit more about that. So Industry 4.0 is kind of the digital manufacturing process. It is a business driver that leads people to invest in new technologies to help them improve their processes by automating things that are repetitive, that maybe have been manual, and helping to track and gather information all throughout the process so that they can help to identify where problems might be occurring. And in a lot of ways, it's a cultural transformation. Some people do resist change, because they're invested in the current process. But it is important to understand that the culture has to change in order to get into the future tools and automation that help you, for your business bottom line. So this chart I know is very, very busy, but it's representative of an example of some of the different areas involved with um, Industry 4.0, as well as the different kind of tools that are applied in different steps along the way. So if you look across that first row, the process flow is product engineering, manufacturing, purchasing, etc. So that's kind of the steps along the life cycle. And then the AI learning is something that can be applied to learning common parts and equipment under product engineering, predictive and preventative maintenance in manufacturing, purchasing contracts and some of the repetitive tasks under the procurement phase, financial. There's ways that the applications can be applied throughout. And in the bottom row there are different vendors and tools that can be applied to help along the way. And these are not endorsements of any kind. It's just representative samples of those kinds of tools. Now, one of the things that is important to emphasize is that Industry 4.0 is not a specific destination. It is not a single place or space in time. It is a process, and it is a spectrum. It is, there's many different things you can do to apply these solutions to improve the errors in your processes, because without having to do everything that's possible, right? If you do, you can certainly overspend and throw technology solutions at problems that maybe don't need all of those bells and whistles in order to address the real root causes of the problem. So one of the things I just clearly want to make you understand is it is a spectrum, and you can maybe you need to be at kind of the one end of the spectrum and not all the way at the other end with all of the things that could be applied. So we see digitization all over the place. There's things changing every day, every week. New technologies are available, and the possibilities are endless. So what we like to emphasize with our customers is to right size the solution to their issues and needs. There's many different constraints to consider. You've got the budgetary constraints, you've got technology constraints, you've got time constraints that maybe there's only certain windows of time where they can apply um, changes to the manufacturing floor. All of those things have to be considered. But first and foremost, we start with data collection. Without data collection, you really don't know where you're starting from. So you need to know where you're starting from, what data you've got, and where it helps you point to the issues that need to be addressed. And then you can start looking at the digital processes and understand where those where different tools might be applied. It's about digitizing and automating things that are being done in the within your process. Correct tool selection is extremely important. Um, again, cost related. You can easily overspend and apply too many things that will be not cost effective for what your business requires. Step three would be taking things into the next level of predictive maintenance. So now you've got lots of data, you've got information that you can analyze, and then now you can say, hey, you know what, we're seeing trends that when we see these numbers reach this point, it means that so many days later things might start to fail. So we can start using that information to make decisions ahead of time and be more proactive and predictive in how we're applying that information. Um, and then going on to the next level above that is self-adjusting machines, using perhaps AI technologies to do that kind of analysis that I just mentioned, understanding those trends, understanding those triggers that can lead to larger problems and variances that are getting too much to be uh, adjusted for and accounted for within the quality standards. So again, examples off to the right hand side, not an endorsement, just the kinds of representative tools that can be applied in these areas. Another thing that is important here is to understand the visibility. And one of the things that we like to do for our customers is to create dashboards and integrate that data into a digestible display that they can use to see what's happening. It can have live data feeds. It can be batch feeds. There's a lot of different sources of where information can come from, and we can integrate those into a dashboard like these examples on the screen that allow you to be able to see and understand what's happening, in different processes along the way. It could be, and available at just about anywhere, with the smartphones and everything that you have. You can access these things wherever you are in whatever format you need to to digest them and understand them, and and have that information accessible to anyone who needs it as well. So whether it's the CEO that needs to see certain executive level reports, or the supervisors and managers on the floor that need to be able to understand what's in their scope. Those can all be tailored to different audiences as well. So giving that visibility is very important to make use of all of that data that we've been gathering and analyzing. So just some quick samples of error proofing and technologies and things that might fall under that Industry 4.0 umbrella. Quick example is augmented step-by-step visual aids with vision systems verification. So think of a work table like you see here with the numbers 1 and 2, and you've got a projector overhead that's looking at what's going on the table. You've got a camera that's also looking at what's going on the table and understanding what's supposed to happen. And the projector can say, okay, here's the bin that you need to go to for your first step. You can grab, and it can tell you to grab, 2 components from that. Then it can light up the next bin that says, okay, you need to take 2 components out of that bin. And then the vision camera can watch you as you take the numbers and say, oh, wait, you grabbed 3, you only need 2. Or you only grabbed 1 and you needed 2. And then as you go through the steps of the process, it walks you through with those visual aids and those visual corrections that help you to help the user to do that assembly process in the correct order and using the correct equipment and components required to assemble that component. Training and retraining is also very important for those, because we have manual labor that's involved with most of the things that we are doing. We don't have completely automated plant floors that people have envisioned many years ago. But doing videos, similar to that step-by-step process, and watching those videos, and also doing augmented and or virtual reality, which is where some of my background has been focused on years ago, is using VR applications to help teach and instruct people on how to do the processes that need to be done. And I've got a little video that can kind of show that on the next slide. And then similarly, AI vision systems that record deviations and predict when tolerances exceed limits. So having the vision system that is looking at um, the welder here and seeing the little green dots of where the welds are supposed to go, the vision system can start to say, hey, these welds are starting to vary more than the tolerances that we've defined. And you can start raising the red flag and saying, hey, we need to make an adjustment, and do those things proactively, instead of waiting till we find out later during a teardown that the welds are not being done properly. So using these tools early on in the process to avoid problems, instead of finding out later during a quality check that something didn't get done right. So if we go to the next one, so this is a brief little video that we had done. It's not professional, it's not not polished in any way, but it is an example that we captured for one of our customers on the plant floor using a headset, and you can see on the screen, within the screen, that you can see the parts that are being applied and that they're being assembled in a certain order. And then the blue boxes that show up on the screen are also giving additional information on what you need to do and what are the tools that you need to do. So again, these are reinforcements to help people to learn and understand how to do the processes that they need to get done in order to do the job correctly. All right. So just some quick notes of experience that I wanted to highlight is before we get into the specific details of a few projects. Analysis of plant operations to improve efficiency and quality, which resulted in reduced costs. So that's one of the things that we've done, is to come in and help solve the problems. We've got a problem on the plant floor. We've got some things happening. We're not reaching the targets we're supposed to reach as far as time and quality. And we go in and we observe and do follow the steps that I showed earlier of how to gather data and come to conclusions on what is needed to address the issues. We have extensive knowledge and application of best practices to help bring creative new ideas to customers, and we have that that multi-customer, across the globe experience that help us to say, hey, we've seen other people do X, Y, Z, and we think that would be very suitable for you to do some things similar to that. But to help bring new creative ideas and challenge the status quo. One of the quotes that we like to use from Einstein are it's not, you can't use the thinking that was used to create the problem in order to solve the problem. So it helps to have that some people to give you an outside opinion and point you to some things that maybe aren't so obvious to the people that are experiencing it day in and day out. Implementation of digital transformation solutions for many OEMs. We've done this, many places, many times at different customers across the globe, and again, emphasize right size the solution to the problem. We're not in the business to sell technology. We're in the business to help customers solve problems, and it's very easy to overspend based on some others that may have an emphasis on selling you what their technology is, as opposed to addressing and solving the specific problem. We've also done a lot of work with cost analysis to determine the where to put emphasis on solutions to be cost effective, and weighing manual improvements versus automated improvements, and helping to to identify which is the best to apply to the given situation. And then we also have a capability to take a clean slate approach to kind of start from scratch and say, okay, if we were to do this thing, from the beginning, how would we do it, and what would be the best things to implement? And that's kind of that proactive solution that I mentioned earlier, using the knowledge and experience that people have in order to avoid problems to begin with, as opposed to doing it in the way it was always done, and solving problems later. So just some quick highlights before we get into some specific examples. So with that, I'll ask my colleague Diego Raviolo to maybe do a brief introduction of yourself, and then we can talk a little bit about some of the projects that we have here. So Diego.
Sure, no problem. I hope that you can listen to me okay. I will go very quickly for some examples. This is a system that put in place South America and Brazil. Actually, the initial information was from France, and Renault company was responsible for this contract. They provide to us a digital solution to produce the hemmings on the external panels for a model that was manufactured at the time in Europe and was moved to South America and Brazil. We make a discrete event and a simulation. We update process, floor space requirements, and volume. And using the simulation, we were able to reduce the initial process from 11 robots to 4. So you can imagine the cost reduction in implementation allowed us to go further with the available budget after the reduction, and we incorporate things from Industry 4.0, like automatic calling for maintenance, automatic self validation of the robot hammers. We incorporate self testing of the rollers. The rollers calculate aging, the robots calculate aging on the rollers and automatically request the spare parts to the United States provider. So it was a very challenge, global and multi-language solution that was implemented downtown in Brazil.
I just want to note that in the green text down there, what we were able to achieve better fit and finish performance at the prototype phase versus the European production plants that have been building the same product for some time. So I think that kind of goes to that proactive process of implementing quality from the beginning instead of trying to do it the same way that it's been done, and deal with problems later.
The only quality issue that we had on the initial prototypes, you remember me, thank you, Rob, was we call it explosion of the sealer on the hemming areas, because it was manually applied, not by the robot, was manually applied for the prototypes and was, say, overfeeded into the system. So the only quality request was the extra sealing that we put on the prototype parts. Yeah.
Okay.
This was an example of a vision system that was successfully implemented in Mexico. The plant was running a very bad situation in terms of direct run at that time. We made an assessment of the plan. We recommend several actions. We categorize these actions into those categories that you can see there from A to F. The ones that were related to equipments were handled later by us, implementing an improvement on the booth. The downgraph of the booth were actually not so good, and we put an automatic system to track that, calling for maintenance in case of filters changes will require, or any metrics from the booth changed quality and was automatic calling to maintenance. The additional equipment was a vision system to analyze quality of the reflection quality on the paint surface. And with that, in a few months, we were able to improve direct run from 23% to 85%. That was the target of the initial project. Currently, they're running a better quality because there were additional actions that were incorporated in the system later by the customer directly.
Yeah, and I think just to reiterate, there was a variety of changes that were proposed. Some of them were changes in training, some of in human best practices. For instance, there was dust getting into the paint areas because they were using the same rags over and over again, and it was just simple little things like that that were maybe wasn't obvious to the people on site. That a fresh set of eyes was able to help them make note that no, you can't do these things because you're causing problems, X, Y, and Z because of what people are doing. And so a little bit of retraining, a little bit of manual instruction to some of those areas, in addition to some of the technologies that were proposed as well. So again, right sizing a solution to the customer's needs, helping to um, solve the issue that is most important, and you can see the huge improvement in quality. Diego, why don't you talk about why they had to scrap some vehicles because of the reruns?
Your initial comment was the additional comment was correct. You can see that in the 4 initial months we were able to improve the 23 to 55. None of these actions were actually capex actions. So without an extra budget, just correcting behaviors like close the doors when the truck is coming into these kind of things, we were able to improve almost 23, 25%, 22% the direct run. Those were without capex. So not all the time the improvements are related to budget expenditure. At that time, when the car that you can see, the red one that you can see on the first slide, were rejected at that time due to were so many times repainted that the paint thickness was the problem. So you can imagine that after you repaint the car 5, 6, 7 times, there's nothing else that you can do. You need to start over again and scrap over thickness. That's the very first time in my 32 years experience that I see these kind of things in a paint shop. Reprocessing, waste.
Yes, very unusual circumstance for sure. All right, why don't you go ahead and talk through this one?
This project was a very challenged project from the data gathering information at the beginning. Was initially a 1.5 year project that was, due to the results of this 1.5 year, was extended to another 6 months, another 6 months, another 6 months. We finally end this project, incorporate almost additional 2.5 years of other improvements because the first initial phase 1, was really well received by the customer. The project involved us in all around Europe, moving a complete platform from they call it B9, was a very light, this a light commercial vehicle platform from the company Stellantis at the time, from Europe to Russia. The company that you can see there is PCMA Russia. It is in Russia, but it's a company that is located in Kaluga, nearby Moscow. The tooling that we were able to transfer was actually moved in 400 trucks, covering all regions that you can see in Europe. And the total weight transfer was a little more than 10,000 tons on tooling. I'm currently in Paris, so I will use that reference. The Eiffel Tower weighed 11,000 tons. So we actually move in trucks when Eiffel Tower in trucks from Europe to Russia. Localize the tooling in Russia was an additional challenge because the capacity equipment available in Europe was not available in Russia. So you have a press line in Europe, and if you're moving the dies, the toolings need to have the same feather. So find a feather for those tooling in Russia was another challenge. And you can imagine that moving this amount of tooling require a lot of data gathering initially to understand from where to where are the tooling's conditions, where are the administrative conditions, who was the owner, if it was full paying, if it was belongs to the customer or belongs to the suppliers, what is around the assembly lines nearby the tooling. Was a very large detailed program. We were able to complete that successfully 21 days before the war started. So that was a very good timing to finish a project.
And just want to emphasize, 250 different suppliers, 12 countries, 124 different cities, 3,000 uh, tools assessed, 34 welding cells. Just so the key takeaway from this is data management and managing all the information of all these different tools. And that kind of leads into the next slide here that talks about the dashboards that I mentioned earlier and tracking this information and having it available. And bottom line is traceability, being able to trace, from, how it got to where it is, all the way back to where it came from. Diego, you want to?
One more comment, Rob. The platform that was transferred to Russia was running production in some cases for more than 12 years in Europe. You can imagine at that production volume how many vehicles you can find on the streets. Spare parts availability was the driver for this project, not production, honestly. So we need to keep feeding the distribution centers with parts during the transfer. So it's not only production transfer, it was also spare part stock, buffering, production buffering, and transfer with a really limited time to be able to restart production without affecting spare part availability in Europe.
And here's some other screens, again, from that uh, same work that talked about. Actually, these might be from another project as well. But again, the same idea of tracking information, having it visible, and being able to look at and understand the status for the customers, and the management leaders that need to see information and understand what the status of things, are at any given time. And one last little slide of text here before we get into some Q&A. So just some other real life examples. Vision systems incorporated for assembly processes, verification and alignment of control. Again, using some of the technologies that are available for specific purpose to address problems. And I don't know, Diego, if you want to, expand upon some of the bullets that you have here.
Yep, I can. For a company in the state, we create a bill of material kitting preparation. They were running production for more than 172 different product variations. The diversity was killing the company at the time, and we were able to create a preventive sequence production and control the out of stock material on the warehouse. And all this integration into the systems allow them to schedule production without facing a model in the line without the parts to put it together. The third bullet is, as I mentioned, hemming projects. In all our hemming projects, we incorporate self-test validation rollers and hammers, sorry, wearing signals. The cells defends by itself. And in one particular company, we were able also to communicate this information from the PLCs to the maintenance system. And the maintenance system has incorporate an automatic schedule and spare part request to the suppliers due to they have an open purchasing order with some of them. So actually the robot requests a new say oil changes, and the oil changes was automatic requested for the supplier. And when the system confirmed that the oil was available and the plant, the same system scheduled the downtime or the shutdown for the cells to incorporate to perform the maintenance. So that's integration in the last project was very extensive due to the plant was ready to incorporate those kind of integration across the different areas. On body shop fixtures, we are used to incorporate a vision system or part sensor system to be sure that the operator load the part on the correct rotation, or it's not flip over, or it's not in the correct and incorrect position. And at the same time, we confirm that all the parts are there and nothing goes into automatic if any of the parts are not correctly loaded and located into the fixtures. Fluid fillings, say air condition filling, cooling system, brake systems, wiper washing system, whatever, all the fluid filling systems that are used to be installed in the industry. With the same thing, we were able to link the equipments, scanner codes, QR or barcodes to the production control, so we can confirm that the model that we are filling is the correct one, and the amount of fluid that we put in there, or the percentage of cooling versus water, it's okay. So we anticipate production sequence, and we take all this setting up out of the operator hands, but the machines defend by itself, creating this error-proofing system. And as I think that most of people knows, these electronic torque controls with DC tools and some of these are incorporated into the AI systems and vision system to not only record the torque, control if the all the torques are correctly applied, that we are not torquing 3 times the same screw, and these kind of things are other examples that error proofing that can be incorporated in the working cells. That's it, Rob.
That's great. Thanks so much for adding some extra color to those. So with that, that's the end of the prepared material that we have. We can go into Q&A, and we'd be happy to address any questions that might be out there.
Thank you, Rob and Diego, for a great presentation. It's very clear. One size does not fit all. You shared a lot of great examples of what you've done with clients. But obviously data in digital dashboards, data is really important, how you gather it, why you gather it. And it's evident that your team and your solutions are right for the industry. So we do have some questions to come in our few minutes that we have left together today. So let's get started, okay? So my budget's limited. You know, you had some resources on there, but if your budget is limited, how can I address some manufacturing issues? Where should they get started? Can you or Diego take that away?
Sure. Certainly as we hear in other areas, first step is acknowledging you have a problem. So that's most important. And then once you know that you have some issues that need to be addressed, it's you have to start gathering information and gathering data and understanding what is happening and where. And you don't necessarily need to hire high-end consultants in order to come in and analyze things. You can certainly start to do some self-analysis and understand what's happening by starting to record data if you don't have any data already. And if you do already have some data, you need to analyze that information, understand what the trends are telling you, understand what the what you can read from that, and see if there's other holes that you need to fill as far as I wish I knew what was happening back here, and start gathering information at another step along the way. But there's certainly a lot of things that can be done. As we mentioned in that paint shop example, there's some manual process improvement that can be done because people weren't necessarily following best practices. So incorporating best practices, understanding what should be done versus what is actually being done is important. Maybe you didn't train people to do things specifically in a certain way, and they've just kind of doing it however they choose. So having a best practice, having a standard operating procedure is important as a baseline first step. And then you can start looking at things that might be maybe more um, involve introduction of different technologies and things that depending upon what your budget is, as you maybe get some small successes with some smaller improvements, you can then use the savings to then reinvest into incorporating more improvements and having bigger impact down the road. But that's a first starting point that would be nice. Yeah. Diego, did you want to chime in on that?
I think that you narrowed the options is not expense by expand. That's not always the answer. I think that in the industry, sometimes you need to act with sense of urgency, and desperate actions sometimes drive you in a wrong direction. I think that this is more to be a sniper more than use a shotgun to try to solve the problem. So it's one by
Yeah, I like
one.
that. Yeah.
Yeah, unbundle problems into smaller problems. Don't try to find the forest. There's just one branch by branch.
And thanks for that. And I think the self-analysis, self-reflection, be honest, get started is important, and it really will get things going. So I appreciate that. Now here's another question. What are you using to create dashboards that you showed in presentations? And for the audience, we will be sharing this presentation after this, so you're going to receive the details, and there was a lot of great information on those slides. So thank you for preparing a great presentation. So what are you using to create dashboards?
Yeah, go ahead, Diego.
Okay. We are used to start with. We have two instances for the dashboard. One is to collect information and see what information is available and in which format provided, but what source. Once we have that, we use usually Power Apps on the Microsoft 365 license that we have. There is a tremendous no-code solutions that we can incorporate very easily there. And due to all these solutions are available 24/7 in any web browser. Actually, it's very easy to going across our customers and make those dashboards available to everybody. So they don't need to pay any additional license or go to any specific training to be able to start using or get or profit from those dashboards. So it's two instances. One is from where the information is coming from and in which format. We put our team to work together to extract the information, put it in a fancy format that everybody can use, and from there we're used to go to Power Apps, Power BI, Power Automate, and all these kind of things.
I know
Excellent.
there's certainly some other commercial tools available, but this is one that we use to customize for our own internal and for our customer needs. So it's tailored to the specific, how look and feel of how people want things to be displayed.
That's great. Thank you for sharing that. One last question before we wrap it up. How does Osirius keep track and assess all the new technologies and processes and quality improvement? That's a lot in one question there. So if you can unpack that, that would be great. Technology is moving very fast. You've got a very deep knowledge in your organization. So if you can unpack that a bit, Rob or Diego, that'd be great.
Sure. Yeah, I'll start. So, our one of the things that our team brings to the table is that we are very curious people and we like to know what's going on. And so, in addition to the great depth of experience that we have, we are still curious and want to learn more and understand more about what's going on out there. So we each of us have our own methods and ways of keeping abreast of things, whether it's newsletters and looking through following different people in LinkedIn or other social tools like that. But we have this curiosity to understand what are other people doing, what's new and different, and how can they be applied to our situations that we're working with our different customers. Diego, did you want to add to that?
Yeah, I can add also that our organization is not only global, is diverse, and having people from different regions with different experience, contacting and having access to different customers, different industries. Most of the time, the solution is into our internal team. So um, consultation across the regions or across the teams, putting together a problem into um, um, a meeting a meeting room and say that we're doing this, we're trying to do this, and say, man, I have an experience in a past project that they solved it with easily doing this. So most of the time we use our internal experience and our access to different customers, absorbing from that experience what is the best on benchmarking on the um, on the industry.
And then internally, we have multiple different communication channels, chat groups, whether it's a phone or computer based, but we share those. When we do find interesting nuggets, we say, hey, check this out, and we'll share across our team about different things and how they're being used. And hey, could we use this, for the customer X over here, and see if it helps to address some of their issues.
That's one of the
Great.
reasons because I moved to France. I have a time zone in the middle, so I can connect with my team in the States, in Europe, in India, or in Asia at the same time. Not needing to dealing with 24 hours. I'm in the middle.
That's great. Now this, one last question did come in. So if we could, if you could respond to this because it's everywhere. How to implement AI into your quality measurement inspection? Can you briefly respond to that in our last few minutes that we have together, Diego or Rob?
I can. I'm used to start answering this kind of question saying that AI is not it's not something to be afraid of. It's not a different. It's not a complicated technology. It's in between us and every day. Smart solutions available for data gathering, especially in the vision system. A Tesla can drive a car itself using cameras. You can imagine the amount of information that they can read just through the cameras. So it's not an out of this world technology. It's already embedded and living with us. So camera systems are already available in the market to recognize objects, to compare pictures with the reality, to try to find patterns. They can scan our license plate at 150 miles per hour. So the technology is available. How to use it is the problem. We can use barcodes. You can use QR codes. You can have different system to different technologies to acquire information. How to use that information later is the problem. That is the challenge.
Yeah, yeah, yeah. AI, in its basis form, is a learning algorithm. So you have to teach it some basic information in order to get started. So in that example where I had the weld placements, you have to kind of teach the tool what it's supposed to see, and then and then you have to explain to it that it needs to tell you when things are deviating by a certain tolerance, right? So it's not I guess what I'm getting at is that it's only as smart as the information you're feeding into it. So you need to make sure that you give it enough information to know what's good and what's bad before it can be useful to your business need.
Thank you for that. It makes sense. It's in front of us. So, and it sounds like you and your team are on top of that AI, which is everywhere around us. So that is it. That's going to wrap us up for today. So Rob, Diego, Osirius Group, thank you so much for a great presentation. As I said, we will be distributing this after this presentation. So thank you again for joining us. I wanted to let you know to mark your calendars for our next presentation, which will be March 19th, I believe, and we are having Thermocalc present. So I appreciate everybody joining us. Have a wonderful day. Rob, Diego, thank you.
Thank you all. Have a
Thanks, Bob.
great rest of the
Thank
day.
you. Bye-bye.
Take care.